Assalamu alaikum warahmatullahi wabarakatuh. Dear students, in this video, we are going to solve examples of practice set 5.5 which are based on midpoint theorem and converse of midpoint theorem from the chapter Quadrilaterals. First example, in the given figure, that is in triangle ABC, point X, Y, Z are the midpoints of point X, Y, Z is the midpoint of point X is midpoint of AB, Y is midpoint of BC, and Z is midpoint of side AC of triangle ABC respectively. If AB is equal to 5 cm, BC AC is equal to 9 cm, AC is 9 cm, and BC is 11 cm. BC is equal to 11 cm. Find the length of side XY, XY, YZ, and side XZ. Side XZ. Since X is the midpoint, point X and point Y are the midpoint of AB and side BC. So in triangle ABC, point X and Y are midpoint of side AB and BC respectively. So by midpoint theorem, this side XY, when in a triangle ABC, here in triangle ABC, X and Y are the midpoint of sides AB and BC, then by midpoint theorem, length of XY is half the length of AC. So midpoint theorem tells us that the segment joining the midpoint of two sides of the triangle, length of the side joining the midpoint of two sides of the triangle is half the length of its side parallel to its sides, corresponding parallel side. So here XY is equal to 1 upon 2 AC. Therefore XY is equal to 1 upon 2 into 9 centimeter. This AC is 9 centimeter. That is 1 to 1 are to 4 are. That is XY is equal to 4.5 centimeter. This is length of side XY. Now side also, again by midpoint theorem, side Y and Z are the midpoint of side BC and side AC, and YZ is parallel to BC. Therefore by midpoint theorem, length of YZ, a segment joining the midpoints of two sides of the triangle, is half the length of the corresponding sides which is parallel to side which is joining the midpoints. So by midpoint theorem, YZ is equal to 1 upon 2 into length of side AB, which is equal to 1 upon 2 into length of side AB is equal to 5 centimeter. That is 2 1s are 2 2s are 4, which is 2.5 centimeter. Length YZ is equal to 2.5 centimeter. Now first, second, and now third, find the side length of side XZ. So here X and Z are the midpoint of side AB and AC respectively. Therefore, a segment joining the midpoints, XZ is a segment joining the midpoint. So by midpoint theorem, so midpoint theorem tells us that a segment joining the midpoints of two sides of the triangle segment which is joining the midpoint of two sides of the triangle is length of that segment is half the length of the side parallel to the corresponding which is joining the midpoints of the two sides of the triangle. So here xz is equal to 1 upon 2 into length of side which is parallel to xz is BC, that is length BC. Therefore, xz is equal to 1 upon 2 into BC is equal to 11 centimeter. So therefore, xz is equal to, here BC is given as 11. So xz is equal to 11 divided by 2. 2 1s are 2, 2 5s are 10, 2 5s are 10, that is 5.5 centimeter. So length of side xy, answer, length of side xy is equal to 4.5 centimeter, yz is equal to 2.5 centimeter, and xz is equal to 5.5 centimeter. Second example, in the given figure, quadrilateral PQRS and quadrilateral LMNR are the rectangles where M is the midpoint of PR, diagonal PR. You have to prove that SL is half of LR and LN is equal to 1 upon 2 SQ. Now, here it is given that quadrilaterals PQRS and quadrilateral LMNR are rectangles. Therefore, by property of rectangle, that opposite sides of rectangle are parallel. Therefore, in rectangle LMNR, in rectangle LMNR, segment Rn is parallel to segment Ln. Number 1. Also, this Rn is, that is segment Rn is parallel to, that is segment Rq. That is segment Rn is what? Rq, which are lying on the same line. This point Q is on the same side of the rectangle. Therefore, RQ is parallel to segment LN. So, but in quadrilateral PQRS, in quadrilateral, that is rectangle PQRS, but in rectangle PQRS, segment RQ is parallel to segment SP. This RQ is parallel to SP. That is, therefore, now see here, RQ is parallel to LN and RQ is also parallel to SP. Therefore, from 1 to 3 we get that RQ, this LN is also parallel to SP. So from first, second and third, we'll get that here RQ is parallel to LN and RQ is also parallel to SP. So SP is parallel to LN. We get that from 1 to 3, segment SP is parallel to segment LN. Number 4. Now we'll consider twin triangle SPR. In triangle SPR, in this triangle SPR, now segment LN is parallel to SP. From 4, segment LN is parallel to side SP of triangle SPR, and M is the midpoint of side PR. So in triangle, we are considering C. When in a triangle SPR, here side is parallel to the third side, and M is the midpoint of one side of the triangle, then by converse of midpoint theorem, N is also midpoint of the other side of the triangle. So here LM is parallel to SP, and M is midpoint of side PR, one side of a triangle, that is PR, then by converse of midpoint theorem. So converse of midpoint theorem tells us when this LM is parallel to SP, to one side of a triangle, then a segment joining midpoint of one side of the triangle is parallel to third side, then the other point of the second side of the triangle is also the midpoint of the other side. So here by midpoint theorem, point N is midpoint of side SR by midpoint theorem. This is L is midpoint of the side SR. Therefore, SL is equal to LR, since L is the midpoint of SR. So the first part which we have proved. Now second part we have to prove that LN is equal to 1 upon 2 SQ. So diagonal of rectangle LMNR is half of diagonal of rectangle PQRS. So this proof is related to the diagonals of the rectangle, and we know that property of rectangle, diagonals of rectangle are congruent. Diagonals of rectangle are congruent. Therefore, in quadrilateral PQRS, diagonal PQRS, diagonal PR is equal to diagonal SQ, and diagonal, this is number 5, and diagonal in the rectangle LMNR, diagonal NN is equal to diagonal NR. Now M is the midpoint of PR. M is the midpoint of PR. So MR is equal to 1 upon 2 PR. 1 upon 2 length PR. That is, therefore, this MR is equal to 1 upon 2 PR is equal to SQ from statement number 5. PR is equal to SQ, MR is equal to 1/2 SQ. Now, here LM, here since M is the midpoint of PR. Since M is the midpoint of PR, so MR is equal to 1/2 QR. But now here this MR is equal to ln from 6. Therefore, ln is equal to 1 upon 2 SQ from statement number 6. So ln is equal to 1/2 SQ. We have proved it. Third example, in the figure, triangle ABC is an equilateral triangle. Point F, D, E are the midpoints of side AB, BC and side AC respectively. We have to show that triangle FED, this small triangle which is formed by joining the midpoints of the sides of the big triangle ABC, is also an equilateral triangle. So here it is given that in triangle ABC, in triangle ABC, this is midpoint of F is midpoint of AB and D is midpoint of BC. So these are the midpoints, a segment joining the midpoints by midpoint theorem of two sides of the triangle is half the length of the side parallel to the third side of the triangle. So by midpoint theorem, so here F and D are the midpoints, so FD is equal to 1 upon 2 side AC, number 1. Also by midpoint theorem, this D is also midpoint and E is also midpoint of side BC and AC. So segment joining the midpoint, that is DE is equal to 1 upon half the length of the parallel side, that is AB, and third is F and E are also midpoint of the side AB and AC of triangle ABC. Therefore, length of segment joining the midpoints of two triangles is half the length of the parallel side, that is FE is 1 half AB by 1 half BC, 1 half of length BC by midpoint theorem. So by midpoint theorem we get the three statements. Now triangle ABC is an equilateral triangle. Triangle ABC is an equilateral triangle, so we know the property of equilateral triangle that all sides of the equilateral triangle are congruent. So triangle ABC, all side AB is equal to side BC is equal to side AC. All three sides are equal. Sides of the equilateral triangle are equal. Now multiply here this equality by 1 upon 2. So each term multiply by 1 upon 2 AB, 1 upon 2 BC and 1 upon 2 AC. Multiply by equality by 1 upon 2. The value doesn't change if you multiply or divide by equality by any number. Now here from 1 to 3 we get that 1 upon 2 AB is equal to D, 1 upon 2 BC is equal to FE and 1 upon 2 AC is equal to FD. So we can replace these terms from 1 to 3 from first, second and third. 1 upon 2 AB is equal to DE, 1 upon 2 AB is equal to DE, 1 upon 2 BC is equal to FE and 1 upon 2 AC is equal to FD. So here now this FD, ED and D and FE are equal. All three sides of this triangle. Therefore, triangle DFED, therefore triangle FED is also an equilateral triangle since all sides of triangle FED are equal. Fourth example, in the given figure, PD is the median of triangle PQR. PD is the median of triangle PQR. Point T is the midpoint of side PD. Point T is the midpoint of side PD. Produce intersect PR at M. Show that PM upon PR is equal to 1 upon 3. This we have to prove. PM upon PR is equal to 1 upon 3. Draw DN parallel to QN. It is a hint. So our construction is draw DN parallel to and Q, such that P dash, M dash, N dash, R, M dash, N dash, R. In this manner, it is parallel. Now, in triangle PDN, this triangle, or by construction, it is given that T is the midpoint. T is the midpoint of segment PD of one side of the triangle, and line TM, that is QM, is parallel to DN, that is TN is parallel to DN by construction. So when in a triangle, one side of the triangle there is a midpoint, and TN is parallel to DN, then we have to, by converse of midpoint theorem, this M is also midpoint of TN. By converse of midpoint theorem, M is midpoint of segment, the other side of the triangle. So PM is equal to PN, statement number 1. Also in triangle QRM, this triangle DN is parallel to QM construction, and PD is the median, so D is the midpoint of QR, D is the midpoint of segment QR, and DN is parallel to QM. Therefore, again in triangle this, D is the midpoint and this is parallel to QM. So by converse of midpoint theorem, N is also midpoint of side MR. So MR is equal to NR. Now from first and second, we get PM is equal to Mn and Mn is equal to Nr. So PM is equal to Mn is equal to Nr. Now here side PR, this side PR is equal to PM plus Mn plus Nr. P dash, M dash, N dash, R. But from 3, PM is equal to PM plus Pn is equal to Mn. So we can replace Mn by PM, plus Nr is also equal to PM. So we can write Nr is equal to PM from 3. From statement number 3. Therefore, PR is equal to PM plus PM plus PM is 3PM. Therefore, PR upon PM is equal to 3 upon 1, that is PM upon PR is equal to 1 upon 3 by inverted door.